On behalf of National Federation of Engineers for Electrical Safety, I would like to welcome you all for joining for today's important and timely webinar because electrical fire are significant concern in India. So I want to give you a little bit of data. There are around 1,943 electrical fire incidents in 2020, which accounted for approximately 21% of the total fire incident that year. The recent data on electrical fires in India highlight growing concern, particularly due to short circuit. From July to December 2023, India reported 112 electrical fire incidents, resulting to 131 deaths and 164 injuries. These are residential and commercial buildings which are affected. So, electrical short circuit being the leading cause, almost 58% from these cases. Another very interesting part, if you look at NCRB saying that over 1,000 crore or more is a lost property loss. This figure including damage to property, homes, factory, and commercial. So 1,000 crore is lost due to electrical short circuits, various fire. Actually, these figures are quite less when we compare. Actual figure should be much more than this, but this is the NCRB data. So these incidents, the recent fire happened, one in Andhra Pradesh, another one in hospital, another one in hospital in Bangalore very recently, and another one just week back in Hosur, major fire. So this is actually made us to talk about fire due to short circuit. What is it? If you see our conventionally, we always blame overloading, wrong connections, wrong design and all that. But there are something beyond that. That's what we want to talk today. New findings and protection against thermal effect. So we have Gopa Kumar, the president of NFE, who has been forefront of promoting electrical safety standard in India through NFE. He has traveled in the last 18 months, he traveled length and breadth of the country and did over 28 workshops for National Electrical Code of India. I was fortunate enough to travel along with him to understand the psyche of the people. How much are they learning out of all these workshops? And Mr. Gopa Kumar has done over 300 webinars since COVID time. And when we do the statistic, how many people we have touched through this educational webinar, it is more than 50,000 people have been attending various webinars. All this happens because people like you, whenever we announce a webinar, very positive. I'm also very proud to say our average registration of webinar is almost 450 to 500. There is no commercial interest in our webinar. There is no product promotion in our webinar. It's purely learning, sharing, and experience what's happening around us. So let's know what our president, Mr. Gopa Kumar, is going to talk about today's topic. You'll be sharing valuable insight and recommendation, especially focusing on National Electrical Code of India of 2023 and IS 732. Before I move on to the subject, I would like to make you understand that we have an association, non-profit organization called NFE, National Federation of Engineers for Electrical Safety. Again, this is born out of the curiosity, the interest shown by many engineers across the country in our webinars, which started from COVID times. And there was no association for electrical engineer, improvement of electrical safety. So in the year of 2022, end of 2022, we started NFE. And today, I'm so happy to say we are one of the fastest growing society in India, and we have over 1,500 members with 7 chapters across. And for our track record, we have completed 28 workshops on National Electoral Code of India and CA regulation, and we are touching almost 35,000 people through this workshop, and tremendous growth. And we average, we intend to touch 5,000 members by 2025. I'm sure if you are joined today to understand about this topic, so you are very, very keen, and there is tremendous change in learning. And if you are a member, you'll be able to go to the blog and revisit our previous webinars, and there are huge Q&A, question answer been answered, and you can see our blog of our president, Mr. Gopa Kumar also. I would urge people, my friends here, to join NFE as a member, because the cost is only just 1,000 rupees a year, and you can become a member in less than 2 minutes. My colleague Lakshmi and Navya, who is monitoring, she will be giving the link to the society NFE as an association. I would request you, because these are the token of appreciation for us. Somebody becoming member, then he become passionate and he become part of our movement called Make Electrical Safe Nation. So we need you. So I urge everyone to become a member of NFE. And just going back, reviewing, rewinding our recent webinar, which in August on harmonic and switching transient analysis. Then we did CA regulations, panel discussion on August 24. Then we had, switching control assessment on IEC 61439. Then today, the topic is fire due to short circuit, new finding, protection against thermal effect. Myself, I'm Dominic, I'm from the fire industry, and I've been doing these webinars quite often. And speaker, all of you know, Mr. Gopa Kumar is very active in BAS. He is a technical committee member of EGD 20, EGD 30, EGD 50, and also part of National Building Code 2016. Is quite active in IEC, TC 64, TC 81, AC 37A. So he's a quite familiar face. I don't need much of introduction to be given. And actually, he's unwell. He has a throat infection. And today, after maybe 4 or 5 days, I'm able to see him on the screen, and hopefully he will talk. But mind you, please put your relevant question only in Q&A box, and your question should be related to today's topic. Okay, so we will be taking only maximum 10 questions because of his health reason. Will not be. We'll try and close this whole session by 1 hour 15 minutes. Max is 1 hour 30 minutes. So thank you for joining once again. We have a wonderful audience today, and I welcome Mr. Gopa Kumar to take over from here. I will unshare this screen. I'm already unshared.
Thank you very much, Mr. Dominic, for the nice introduction. I hope, let me share the screen. I hope the screen is fully visible now.
Yeah, it's full, sir.
Yeah, I would also like to close the video, which will be better. Yeah. So today's topic, we are going to talk on protection from thermal effect. It's a big subject. Explaining the whole subject of handling thermal effect in an electrical installation in 1 hour probably is a very difficult subject. So generally we make presentation in 2 ways. One is cover the entire subject, touch up the entire subject so that the whole subject is covered, but then people only understand like an introduction of the subject. Number 2, take one of the subject and go deep into it. So today, I will be more talking on fire on electrical equipment. or the electrical products more. Once when we go deep, then you'll be able to understand. The subjects are covered, taken from the National Electrical Code of India, NEC 2023, also from IS 732. You see, with these committees, ETD 20, we are making a lot of standards and we are educating the whole market, the whole electrical engineers community to make safe Bharat. We are spending time, we are dedicating our time for these awareness programs. But unfortunately, most often, sometimes the government fails to appreciate it, and government try to make dangerous installation. This also is a subject sometime we need to speak. One side we are trying to make safe nation, but on the other side, sometimes the governments are trying to make unsafe situation. That also I will try to touch up at the end of the presentation. So, protection against thermal effect is explained in clause 4.3 of IS 732. So I put as chapter 4, but unfortunately, the presentation is totally for more than 1000 slides. So today we are going to talk only about protection against thermal effect. Now, generally, when we talk about thermal effect, we don't use the word thermal effect. We say fire. In electrical engineering or in an electrical installation, there are preventative measures or preventive measures. Means the safety measures which has to be implemented in an electrical installation, which will work before ignition of fire. The problem is fire is after ignition. Why electrical appliance or electrical installation should create fire is the question we should ask. So the preventive measures talk about the measures which we need to implement in an electrical installation, which will work before ignition of fire. Examples are avoiding ignition of fire from electricity. These measures are preventive measures. It depends on the design, selection, erection, and verification of electrical installation, periodic verification, maintenance. These are the subjects which we need to focus once when we talk about protection from, or once when we talk about preventive measure. All these subjects are explained. The preventive measures of protecting electrical installation from a thermal effect is explained in NEC or IS 732. Please note that the word used is thermal effect. The meaning is, under normal operating condition, electricity or a current using equipment or the electrical installation shall not produce a temperature which is more than the capacity or more than the withstanding capacity of the equipment or more than the capacity of the environment. So the temperature itself has to be limited by various measures so that the chance of ignition or the protective measure, these are after. Protective measures are after the ignition of fire. Protective measures such as smoke detection, fire suppression, and reduction measures for smoke or fire extraction, fire drills, means of escape, access. All these are protective measures, but after the fire. Whereas when we talk about thermal effect, we are talking about the measures which has to be implemented before ignition of fire from electricity. Unfortunately, in one of the recent fire accidents happened in Chennai, in one of the factory, the reason which the media reported is the operator forgot to switch off the the switch to a small appliance or for a small test setup. The operator forgot to switch off the electricity, which resulted in a fire, which resulted in 2 days shutdown of the factory. So if you go deep into it, this is not the correct way. Every circuit should have preventive measure. Once when the temperature is going more than certain limit, the preventive measure should act and it should disconnect the supply. Automatically it should disconnect the supply. That is how it is. And here the subject is, most often we very rarely talk about the preventive measure. When we talk about fire, we always talk about protective measure using more and more sprinklers, detection, and all these things, because it's a big business. More fire, more business. Whereas in preventive measure, it's not only business of the product, but this is knowledge of the designer, knowledge of the installer, knowledge of the person who verify the electrical installation, finally decide how your installation is protected against thermal effect. One simple example is, imagine you have a lighting circuit where the total size of the light, the total load is only maybe 2 amperes, 3 amperes. But if you put an MCB of 16 amperes and put a 1.5 square mm wire, of course you will be in trouble, because you are not conventional system. Maybe conveniently what we are putting, maybe people say, I am using this style 16 amps MCB and 1.5 square mm wire for the last 25 years, no fire occurred. This is not the correct statement. So each of the protective device has to be designed and selected, erected according to the requirement. Here, it is not the product which is deciding the safety. It is the knowledge of the engineer who is selecting the product and installing the product decide the safety of the installation. So there is a big difference in these two cases. Preventive measures, as I said, preventive measures are about the knowledge of the engineer, and protective measures are after the fire. Prevention is better than cure, all of you knows very well. Standards and code of practices are made based on science, and science prevails. Products shall be used and maintained as per the standard. In a lot of cases, exaggerated claims of product may be disastrous. Sometimes some manufacturers claim that I have a wire which is made because of so much technology into it, and my wire will never catch fire. These are the claims which happen sometime in the market. Don't believe such claims. Open the standard, find out what is written, find out which standard the product is tested for, and use it according to the recommendation of the standard. That is the best way. Now, coming to the point, protection against thermal effect. There are two major subjects. The first is protection against thermal effect itself. Here the subjects to be discussed are protection against fire caused by electrical equipment, means the equipment is catching fire, how this is handled in the standard, how this is handled in a product, precautions where particular risk of fire exists. That means in a location, the chance of fire, the risk of fire is more. What to do in that particular case? Protection against burns, protection against overheating, and arc fault detection device. Of course, our AFDD is a part of protection against fire caused by electrical equipment. So these are the measures which is determining or which is protecting against the thermal effect. There is one more subject, overcurrent. Overcurrent also creates a thermal effect. An electrical installation, as a mandatory requirement, need protection against overcurrent. So here the safety measures are protection against overcurrent by automatic disconnection of supply, protection against overcurrent by other means. There are various means: controlling the current, for example, limiting the current. For example, once when there is an overcurrent, the source itself is designed in such a way that the current is limited to less than certain amount is one of the technique. Protection against overcurrent by limitation of characteristics of the supply, protection of conductors in parallel against overcurrent. So basically, there are two subjects, thermal effect and overcurrent. Today, we are going to talk only about thermal effect, and I will be focusing more into protection against fire caused by electrical equipment. Now, common cause of ignition encountered in electrotechnical products. IEC 60695 Part 1. Short circuits. Short circuit is a direct contact of live part at different potentials. Please note that a contact between a live conductor and earth is not called as a short circuit. It is called as a earth fault. So here short circuit means between the live, between face to face or face to neutral, there is a contact. The reasons are it is written in the standard, included in the standard, loosening of terminals, disengaged contacts, ingress of conductive foreign bodies, and so on. Gradual degradation of component, sudden failure of component or an internal part is the origins of short circuit, identified origins of short circuit, and the consequences and effects are also included in the standard. Protection device may not get activated. The first one means the device, the protective device such as fuse or MCB is not working properly. It is not tripping in time is the first cause. The rise in temperature is significant after very short time and may be localized. Emission of light, production of flames, ignition and the surrounding components, the releasing of glowing material. These are the consequences of short circuit. But if we look at analyze the after a fire incident, if we analyze the entire installation, most often the reason is serial number one, protection devices may not get activated, or the rise in temperature is significant after a very short time and may be localized. These two are the two majority of the reason for fire from short circuit. This also means the first one, protection device may not get activated. If the protective device is working properly, then there is no chance of fire. There is no short circuit because the device, there is a short circuit, but the device tripped as a result. No fire. That is the way it should. The preventive measure is automatic disconnection of supply. The second cause of fire is accidental sparks or arcs, external to the product, internal to the product, and sudden failure of a component or an internal part, which is creating the consequences are protection devices may not get activated. Again, here also the same reason, emission of light, smoke, and flammable gases, production of flame, risk of ignition of potentially explosive atmosphere. Ignition can occur locally in surrounding components or gases. So basically, the accidental sparks or arcs is also as identified reason, the origin is identified and the consequences are recorded. Then the transient current, then abnormal temperature rise due to overcurrent, defective contacts, earth leakage, and so on. So basically, with respect to fire from an electrotechnical product, such as maybe some of the appliance which we are using in our house or maybe some equipment which we are using in our industry, the reasons are very much identified. It is a mandatory requirement that the safety measure has to be inbuilt in this particular equipment. Example, for automatic disconnection, there can be a fuse. If there is no fuse internal, then the manufacturer will tell you very clearly that fuses must be provided external. Example, a motor, the overload relay and the short circuit protections are sometimes made external because there is no internal protective measure. So depending upon the equipment, these measures are implemented. With respect to the fault and fire, a fault is equal or it is proportionate to the energy used in the equipment, which is proportionate to the heat, arcing or resistive heat, which is produced because of a fault. Let me skip a little bit of this too much theory part. What happens fire? It is the energy which creates the fire or thermal effect, not fire, sorry, thermal effect. The thermal energy produced from the appliance is the reason. The thermal energy is calculated as the average power multiplied by the time. So I into V into power into T. You can find this information in the standard 60695 part 114. So basically, the standard analyze the reason for fire. Why this analysis is made is finally the equipment, it is the responsibility of the equipment manufacturer to take the equipment for various kind of testings. Testing, for example, you can see fire safety. You can, let me show you one of the testing. For example, glow wire testing, hot wire based test, glowing hotware based test methods, glowware flammability test method for end product, glowware apparatus and common test procedure. So basically each of the product undergoes certain test. It is based on the type of the equipment, the energy which is used, and in case of a fault, the duration, the time with which the devices are going to operate, or several influencing factors. You can have a look at the particular standard. You will get a lot of idea. One of the concept which is recommended or which is included or which is considered in the standard is the heat produced because of a fault, if it is for less than 15 watts for a longer duration, the heat produced from a fault, if it is less than 15 watts, it is not supposed to ignite fire. No chance of ignition of fire if the heat produced is less than 15 watts. If the heat produced is between 15 and 100 watts, ignition can happen under certain condition. And if the heat produced is more than 100 watts, of course, electricity, the equipment itself will catch fire. The equipment itself will start burning. This is with respect to the energy and time. Less than 15 watts, chance of ignition of fire is less. 15 to 100 watts, yes, it can ignite under certain conditions. More than 100 watts, of course, it can create a fire. Similarly, with respect to the duration. So even if the peak power produced from an electrical apparatus is, let's say, 4,000 watts, this 4,000 watts is the power limited, the maximum power which can be used in a single domestic or an equipment which is used in domestic or office purpose. The maximum power from a single device has to be limited to 4,000 watts. So more than that, the equipments are not classified for domestic or similar purpose. Higher than 4,000 watts is for industrial purpose. There the test procedures are different. So in a domestic or similar application, even if the heat produced is, let's say 4,000 watts, but if the heat is reduced to less than 15 watts in 3 seconds, within 3 seconds the heat produced is reduced to 15 watts, then there is no chance of fire. Within 5 seconds, if the heat produced is reduced to less than 100 watts, then you can see the yellow area. Ignition may happen depending upon the situation. So this concept gives you an idea. You can find this concept in 60695 part 1. You will get an idea that if the protective device is operating within 3 seconds, then the chance of fire is very less. So within 3 seconds, the protective device, if it operates, then the chance of fire is less. Based on this concept, power source classification is carried out. Power source classification, PS1 means an apparatus which uses less than 15 watts, PS2 is less than 100 watts, PS3 is the power source 3. Power source classification, especially for example, the audio video equipment which is used in our houses, they are made. The quantification of fire. Fire risk is, reduce the probability of occurrence of fire or reduce the consequence. So the probability, the number of fire accidents into the consequence, fire risk can be mitigated by a reduction of the probability of occurrence or reduction of the consequence. Reduction of consequence is not in the hand of the electrical designer or the electrical engineer, whereas reducing the probability of occurrence is very much in the hand of the designer. If the designer of an equipment or the installation or an engineer who installs the device or the engineer who maintain or verify the installation, he can very much handle or he can very much reduce the probability of occurrence, thereby reduce the chance of fire. The probability of occurrence can be reduced by the following factors: product design and selection, including the selection of appropriate materials, containment using fire-resistant enclosures and compartment boundaries, the use of appropriate assembly and installation methods, the incorporation of circuit protective devices, and the use of detection or suppression devices. So these are the measures which can be included to reduce the probability of occurrence. So participants, please don't think that I am trying to take it too complicated. I am trying to put a very, very complicated subject as simple as possible. Because to design or to select these devices, you need a lot of skill. So based on this, the fire tests are carried out in electrical products: small scale fire test, intermediate fire test, large scale fire test, real time fire tests. These are carried out in the products. So that means if you are buying a product which is having the ISI marking, you are sure that the products are tested for handling such unforeseen situation. So it's very important for a buyer to see that the products are in compliance to the standard. If you are buying products which is not in compliance to the standard, we have no guarantee. We don't know what is going to happen. So basically, from the product standard and its test reports, the thermal characteristics of the product is known. Finally, the product manufacturer tells you the amount of heat produced from the equipment under normal condition. He tells you, of course, going through all these complicated testing of the component is not the job of an user. Of course, it is the job of the manufacturer of the electrical equipment. Why I am stressing this again and again is most of or large amount of electrical equipment, electrical devices which we use in our household application are not made as per or not certified as per BIS standards. ISI marking is not existing. Example is inverter, household inverters. There is no ISI marking. These, anybody can make and sell. These are probable causes, or most of the time the fires are from these kind of equipment. So basically, the product manufacturer should give you the amount of the thermal characteristics of that particular device, and he tells you how to install and where to install, how to handle the thermal effect or the heat produced by the equipment if there is any heat under normal condition. The other precautions against thermal effect are precautions where particular risk of fire exists, precautions against burn, overheating, and AFDD. Now, with respect to the equipment, electrical equipment shall not present a fire hazard to adjacent material due to heat accumulation, heat radiation, hot elements, reduction of safe function of electrical equipment, protective device such as protective switchgear, thermosets, temperature limiters, seals of cable penetration and wiring system, overcurrent, insulation faults. So basically, these are the protective measures which has to be, or with which the equipment is able to withstand, or the equipment is already having. Now, what do we do? If you know the thermal characteristics of the equipment, the first subject is to mount the equipment in such a way that the temperature produced from the equipment during normal operation is not harmful to the nearby equipment or the nearby environment, because each electrical apparatus equipment during its normal operation produces heat. The only point is the amount of heat maybe in one product is very less, maybe in another product it may be more, but due to aging, maybe the temperature, the thermal effect is more. From the manufacturer's guidance, technically you are supposed to get these information. So these devices has to be mounted within materials, or I don't want to read it. So basically you have to mount the devices in such a way that the thermal effect is not harmful to the equipment. Some equipment during operation produces arcs or sparks. It's inherent property that once when it starts, maybe there is an arcing. So such products has to be put in arc resistant, inside arc resistant material, or screened by arc resistant material or mounted at a distance to allow safe arc extinction. So you will be able to get the data from the manufacturer's catalog. Electrical equipment in a single location contains flammable liquid in significant quantity. Of course, the quantity is referred as 25 liters. So if an equipment which is having more than 25 liters of flammable liquid inside, then we have to ensure that necessary measures are made in such a way that the liquid is not creating, or the liquid is not increasing the chance of fire. And the equipment which is in and around the equipment during installation, let's say for example during installation you are making a welding, the equipment in and around shall be able to withstand that particular installation process. There is a device called as AFDD, which is recommended in NEC. AFDD stands for arc fault detection device. Now, AFDD, there is a small difference of recommendation in the IS 732, basically the IEC 60364, and in our National Electrical Code. In IEC 60364, the AFDD is recommended in premises with sleeping accommodation, means where you have bedrooms. In NEC, it's a little bit more clear. You'll be able to see in the next slide. It is recommended in location with the risk of fire due to nature of processed or stored material, example BE2 locations. In locations with combustible construction material, CA2 location. In fire propagating structure, CB2 location. And in locations with endangering irreplaceable goods such as museums or heritage buildings. So if used, AFDD shall be placed at the origin of the circuit to be protected. Now this device, AFDD, has been recommended in both NEC as well as the IEC 60364. What happens is, AFDD is a device which will detect, it's a very sensitive equipment, it will detect the arcing, continuous arcing happening in a circuit. And if the arcing is more than certain energy, let's say for example 2.5 amperes, then the device trips. Please note that using electricity safe is one requirement. Similarly, continuity of power supply is also a mandatory requirement. Due to unnecessarily, or let's call as nuisance stripping. Nuisance stripping should not disrupt the power supply. The devices, each of the protective devices has to be selected and erected in such a way that these are operating only once when that kind of a condition exists. Now, with respect to AFDD, the NEC is recommending as below: in premises with sleeping accommodation, in bedrooms and habitant rooms, in kindergarten and daycare centers for children, disabled and elderly people, in bedrooms or habitable rooms, in barrier-free accommodation for handicapped persons, and in locations 1, 2, 3 with risk due to nature of processed food and so on, nature of stored material. Now, please note that in NEC, up to 63 amps is mentioned, but practically no companies are making 63 amps AFDD. This is what I learned from the market. First of all, AFDD is an additional protective device which has to be used not in every circuit, but in some circuit where a chance of fire could kill people. If you try to put AFDD in every circuit, it will create only nuisance stripping. 2 years back, one international company, for their warehouse, they installed AFDD in almost all the circuits. After 6 months, they realized that due to the amount of the workmanship in our country, due to poor terminations, arcings happen and the AFDDs started tripping. After 2 years, they replaced or they bypassed or they took away the entire AFDD. So even though there is a solution available, please use it according to the recommendation of the standard. Don't try to use it everywhere. So these are the measures which is recommended for protection against fire caused by electrical equipment. As I said, please note that I am not going deep into the subject because it's a very big subject, because it's like connecting several standards. Once when we start with IS 732, then we have to go to the next. It goes on in a large way. The second subject is protection against precautions where particular risk of fire exists. Here, for example, with respect to nature of processed and stored material, electrical locations are classified into BE1 to BE4. BE1, no significant risk. BE2, fire risk. BE3, explosion risk. BE4 is contamination risk. So here we are talking about fire risk. So explosion and contamination is much more serious problem. So this is it is much more serious. Now, with respect to fire, for example, in locations where a particular risk of fire exists, the amount of electrical equipment used in that particular area has to be restricted. Don't try to put so many electrical apparatus in this particular area, because there is already a chance of fire exist. The wiring and wiring in system through which, if the wiring is passing through this particular area, you have to take care in such a way that the wiring, you can read wiring and wiring system through these locations are either embedded in non-combustible material. Only non-flame propagating wiring system shall be used. They have no connection along the route inside the location. That means no joints in this location unless these connections are placed inside flame retardant, flame resistant enclosure. They are protected against overcurrent. Bare conductors shall not be used. So the last one, bare conductors shall not be used. Let me tell you an example. Several of the industrial or medical areas, let's say hospitals, the condition where the chance of risk of fire is high exists. One of the recommendations of the standard is you are not supposed to use bare conductors. Example, the protective earth conductor. In India, we have the habit of using galvanized iron strip as protective conductor all over the plant. If you use GI strip, which is having joints, bolt nut joints, which is in this particular area, it's a violation of the standard. You are not supposed to use bare conductors. Better is to use continuous conductor, a fifth wire for this particular application. Temperature in normal use and foreseeable temperature rise during the fault cannot cause a fire, because then you have to have safety measures. Thermal cutout should be manual reset only. These are the safety measures, some of the safety measures which is recommended in locations where chance of fire is more. One concept which is included in the standard with respect to the condition of evacuation during emergency. With respect to evacuation, the electrical installations are classified into 4 types: BD1 to BD4. BD1 low density easy exist, BD4 high density difficult exist. Here, the recommendation from the National Electrical Code or from the IS 732 is authorities responsible for building construction, public gathering or fire prevention may specify which BD condition is applicable for a given building. So it is the responsibility of the fire department to tell that, okay, this building more than this much size, I categorize into BD1, BD2 or BD3 and BD4. Now, the standard tells you the type of additional safety measures required in these locations. Example, in BD2, 3 and 4, wiring system shall not encroach escape route. Several measures are there. I'm only showing you 1 or 2 of the measures. Wiring system shall not encroach on escape routes unless the wiring and the wiring system is provided with sheath or enclosures provided by the cable management system itself or by other means. So open wires are not allowed in the escape route, which is, I would say, very common in most of a lot of buildings, especially the government buildings in India. Wiring system encroaching on escape route shall not be within arm's reach. That means it should be, even if there is a wiring system in the escape route, it should be 2.5 meters away from the ground, unless they are provided with protection against mechanical damage likely to occur during an evacuation. The material the materials used. Wiring system in escape route shall be as short as practical and shall be non-flame propagating. The wire should satisfy certain requirement. The cable trunking system shall satisfy a certain requirement. Cable trace something. The power track means the busbar trunking. Each of the product which is used shall satisfy certain requirements. Example, the wires which is used during fire condition, the wires produce smoke. So, and if the smoke is thick, then you may not be able to see the escape route, or you may not be able to see the exit signage. So what is recommended is the plastic material which is used. It can be FR, FRLS, FR, HFFR. So many names are there in India. Irrespective of all these materials, the only recommendation for this kind of allocation is to have a visibility, or to have a the correct name is not visibility, but one moment. Let me tell you. Yeah, the light transmittance. The word used is light transmittance. It's minimum 60% light transmittance must be ensured. That means the wires used in this area, especially escape routes in BD2, BD3, BD4, should be halogen-free wire, not the normal wires, halogen-free, which is a special wire. Similarly, in locations BD3, 4, wiring system that supplying safety circuits shall have a fire resistance of minimum 1 hour or 2 hours. Okay, wiring system within the escape route shall have a minimum rate of smoke production 70% light transmittance. Sorry, not 60%, but 70% light transmittance means the smoke concentration must be very less. It should be a halogen-free wire. Similarly, there are safety measures for fire segregation within the fire segregated compartment. Let me skip this. Sealing of wiring system penetrations. There are different requirements for taking care of the installation. One of the last measure to ensure protection against thermal effect is verifying the electrical installation to ensure that the compliance to the standard is made. There are different verification points. Verification starts with inspection. There are about 19 points to inspect, starting with protection against electric shock, which is not the important one with respect to fire, but the second one, presence of fire barriers, other precautions against propagation of fire, and the protection against the thermal effect. It is an point of inspection, which is, you can see on the blue, 4.3 and 5.2.10 of IS 732. After inspection, different testings are also recommended in the standard. For a normal, this is for example, for a normal location, 10 testings, starting with continuity of conductors up to voltage drop. Of course, PAT is not for the installation, that is for an appliance. This is the recommended testing for a normal installation. For special installation, such as a medical location or a swimming pool or a bathroom, you need additional safety measures, and those additional safety measures need additional verification with the in place. You have to have an additional inspection as well as additional testing. Those inspection and testing ensure that the recommended safety measures are in compliance with the standard. The compliance, the safety measures are very much recommended in the IEC 60364 standard, which is nothing but IS 732 in India, and NEC 2023, which explains design, selection, erection, and verification. Please note that these safety measures are impossible to integrate into one equipment. If somebody comes with saying that, look, I have a magic equipment which offers all the safety measures, is impossible. And if somebody makes a claim, It is because the person who makes the claim doesn't know about electricity, doesn't know how safety has to be achieved in an electrical installation. By saying this, I would like to take you to the next subject, electrical safety, demand from the fire department. Recently, especially in last few weeks or few months, we are getting a lot of questions or a lot of information from the market about a kind of a device which, okay, I have put two slides one above the other. Let me show you clearly. The fire department of some of the state, not some, one of the state government started, or the municipality started asking, an IoT based microcontroller device shall be tested and verified NABL accredited testing agency laboratory in accordance with the recognized IS 732 2019 standard. As I said, someone claims that I have a product which is made in compliance to IS 732. Basically, it's a foolish idea. IS 732 is not a product standard, it's an installation standard. It tells you how to select a product, how to use a product, how to install a product, how to verify a product. Now you see this, the complete installation IoT based microcontroller device must be used, and now the fire department of the state government is demanding every consumer to install IoT based device, then only the fire license is provided, then only you will get fire license for this particular device. And they say that it is based on based on a notice issued by the energy department. You can see here 2021 114 energy 5. If we look at this particular notice from the government, 115 from the energy department, the annexure 1, serial number 8, it talks about an IoT based device which is offering all these protective measures, protection to minimize risk of arcing. And you see this 1415 protective measure. I'll show you an English version. The government notice says, according to the Central Electricity Measures Relating to Supply Regulation 2010, to maintain safe electrical installation and prevent short circuits and other electrical faults that could lead to accident, it is necessary to accurately identify sensitive factors that could cause electrical failure. To achieve this, various protective system must be integrated into electrical installation and regular interaction. These protective measures should be, you can see here, protection from minimum arcing, and then the final is asymmetric load. Now, if you further read this particular device, implementing of an IoT based microcontroller system for gathering and analyzing data will enable preventive measures to be taken efficiently. So, there are few manufacturers who claims that they make products which is in compliance to IS 732. First of all, this claim itself is wrong because IS 732 is a product, it is not a product standard. And they say one black box offers all these protective measures. So the energy department made a notice saying that there is an IoT based device, haha, very good, you install. Then the fire department says, okay, based on the energy department, you install it everywhere. Then later the energy department says that every electrical inspector should ensure that this device is installed in all the high-rise buildings. So basically, the subject of thermal effect, before making a fire, it is not a solution which can be offered by one product. It is the knowledge, it is a combination of usage of multiple products in a typical situation, selection, erection, verification. So many subjects are playing important role in protecting against thermal effect. It is basically to avoid ignition of fire from electricity by design, selection, erection, and verification. Whereas the IoT based device offering multiple safety measure is a hogwash. It's a real nonsense. Sorry to say the word. The subject serial number 8 in the government circular 2021 is an example of no knowledge on the subject. I would repeat, the department who has made this particular circular, They have no basic idea of what IS 732 says or what NEC says. Sorry to say that. Various circulars from government machinery, example electrical inspectorate and municipal fire department, is a classic example of failure of government in protecting people and property. By the time you realize that this IoT based device is a hogwash, it will be too late. So be careful with products with exaggerated claims. So this is protecting the installation from thermal effect. Thank you very much. I hope I could give some information about the electrical safety. Sorry for the last part because we are putting lot of time, energy, money, and efforts to educate the market in one side. On the other side, somebody coming and now IS 732 is popular. Somebody coming and saying that, look, I have a box, black box offering IS 732. Then everybody buy and put this particular device. This is really nonsense. Thank you very much. And thanks, Mr. Dominic.
Thank you, sir. With a very strong message to the audience. Black magic box which can prevent fire. Putting IoT in it. What does it say? It'll tell you that yes, there are problems, but does it prevent? That doesn't say. So there are a lot
Sir,
of gimmicks.
the
Yes,
funny
sir.
part, the funny part is, it says you will get an SMS. That means I installed it in my house. Somebody is getting a shock. By the time I get the SMS and open the SMS, what is the status of the person who got the shock?
It's like while driving the car on the road, it'll say, go at 80, but you got 120. And it doesn't assure you that going 80 you still be safe and 120 going is still safe. So it is just I would say misuse of word called IoT in the name of IoT. Preventing fire, is it possible, truly possible? That's what the discussion today. uh, the effect of short circuits move beyond short circuit, what it is. So we have a very good, I'm happy that we've got a very good response and people are still waiting. And we'll take, it's 5 o'clock, exactly 1 hour since we started. Mr. Gopa Kumar took exactly 45 minutes. That is what he promised. So we'll pick up only the relevant questions that is there. And a few people have raised the hand, but I will take 3 hands. Let me see whether Mr. Gopa Kumar able to answer those questions. So, Lakshmi Narayan, I think you got the answer from the presentation. How can we prevent short circuit at home? That is already clearly mentioned. You want to take up that, sir, or can we skip that?
Yeah, I can explain. See, it is by proper selection of materials, proper erection of the different electrical materials. Then you have to test it before using, and you have to periodically test it. So selection, erection, design, selection, erection, and verification. So if you do these subjects properly, of course, you get a very safe electrical installation. As I said, the most often, one of the big problem which we see in the industry is oversized protective device. People only talk about big short circuits, 25 kiloampere, 10 kiloampere, 30 kiloampere, 40. Nobody talks about the minimum current which is required to trip an MCB. So please look at the sizing of the protective device very carefully. You are on mute, Mr. Dominic.
Yeah, our chapter president of Mumbai, NFE, GS Baveja sir is asking, out of 3 type of fire test of electrical product, which shall be chosen as part of tech specification for an electrical equipment. Another point is whether it is mandatory for ISI mark product to undergo such test. Many times it is type tested, batch tested, other indication are mentioned. Kindly explain, sir.
Of course, these are type tests. During the design itself, the manufacturer has to test it. Whether the manufacturer is actually doing the test or not is a subject I am still trying to find out, because very limited facilities are there for this kind of test. Of course, all the leading manufacturers, the big brands where the products are ISA marked, they actually do the test. It is not one or two tests, it's a sequence of tests. It's not limited to one type of test. It's a sequence of tests on the components which is used in the equipment, then the entire assembly itself, and so on.
Okay. Don't put your question in chat box, please. If you put a question on chat box, it will not go on record. I would urge to put it on the Q&A box. Abhijit Lime is saying, can you, in short, explain difference between arc flash, arc fault, and arc flash? There is lot of ambiguity in the terminology.
Yeah, arc fault is simple fault created in a wiring, a low voltage wiring due to a loose contact or due to some simple reasons. Basically, it can be series or it can be parallel. Basically, a series means there is a loose contact. As a result, current is jumping through the loose wire. It's a very small, it's a limited, it's in a very small area. Probably you may not be able to even identify it. But over a period of time, this may be creating a fire situation. Whereas arc flash is an entirely different subject. Here in arc flash, we are talking about, example, live working. So once when you do live working, first of all, live working itself is not a good idea, but under certain circumstances, due to certain reasons, we may not be able to switch off the electrical installation and do a maintenance. So when you do live working, and once when the doors of an enclosure is open, or once when you are in front of a live conductor, and once when you do some kind of a work, there are chances that accidental flash, due to some kind of mistake, there can be chances of flashover of very large amount of energy happens. That is what is termed as arc flash. So arc fault is a local, very small energy phenomena, but for a longer duration, whereas arc flash is a high energy phenomena. Flash, basically, it is during live working. This is one of the way, but we can compare these two in different methods. But for a simple comparison, this is what.
Sir Praveen Instan is asking, for such IoT-based product, what a customer should do. They're asking, even if there's a circular saying that every building must install. How does that awareness? What do the customer do?
In the NFE blog, we have made a very clear statement. We have explained the subject very well. Probably, if somebody is asking to put a device, you take the printout, or you give the link of NFE's website to the authority and tell them that this website says this product will not work. You ask them. If they still insist, then please write back to us. We can help you.
Okay. Lakshmi Narayan is asking, is AFDD similar to GFCI?
No. AFDD is arc fault detection device. GFCI is equal to our RCCB, ground fault circuit interrupter. This is the American name of RCD.
Okay, Firdaus, you wanted to check whether your school electrical system is complies with all standards you have shared. I don't know from which city you are. There is a email ID which my colleague Lakshmi is sharing, the president mail ID. So you may write to him, because we have almost 1,300 members. So there are specialists who can look at your drawing and check whether it is complied. So I would urge you to, just make a note of the email ID. Lakshmi, please, mark the mail ID of our president, so that we can reply to him in person. Okay. And also, most of Mr. Gopa Kumar also does large industrial electrical verification or audit. So anybody is really interested, he can also offer his service. So that's his profession basically. Jay Kumar Gupta, please clarify as to what is the substitute of bare conductor used for earthing in flammable material tank farm storage, or other parts of operational hydrocarbon processing plants.
Insulated and continuous conductors. That means minimum joints, continuous conductor, and insulated.
Okay, I had that answer. Now Haribala is asking, it is usual practice that many homes are required with inverters and battery for backup supply at home. They they are mostly located near the entrance of the home and other critical area. How can we guide in such installation?
Actually, it's a very serious subject. Almost maybe 20-30 percentage of our residences houses may be having inverter, and most often it is put on the at the entrance, and if it catches fire, the likely chance of fire from an inverter is very high. And I really don't know how to answer the question. Probably we can make a kind of a NFE's recommendation on usage of inverter, and it can be published. I hope
Yes,
it.
it's a subject. I think Haribala is there and a lot of people, but there are a space constraint. A lot of people are tenants and all that. Whether we can have a dedicated place for inverter to be placed and exposed outside rather than inside, which battery fumes are not. In fact, my home I have inside, so under the staircase. So it depends. If there's a guideline, like as you said, if there's a guideline where how to install inverter, where to install, where to position, and in case there is a heat generated, how do you automatically switch on the fan or something? So anyway, it's a guideline that we need to work on this. So Pramod is asking how much minimum distance should be maintained from induction motors, three phase, more than 5 HP controller or on off switch.
Oh, I am not sure.
Okay, this is not
Not
the
sure.
subject that we spoke today. Anyway,
Yes.
Balu is asking what are the standard used for selection of protective devices?
If you are talking about OCPD, it is the class 4.4 of IS 732. IS 732 class 4.4. About OCPD, overcurrent protective device. If other protective device, maybe 4.5 also you should refer.
I don't know, you'd like to take this question, which is your against is thermography. How can thermography a preventive measure?
Thermography cannot be a preventive measure. Thermography can be a maintenance measure. During maintenance, if there is not only thermography, you can find out hot spots by using either a thermal imager, or you can also use the IR thermometer. So both thermometer as or thermography can be used. It will tell you the hot spot, and generally you have to reduce the amount of heat produced in the hotspot. But if your installation is in compliance with NEC, the 19 inspection and 10 test, which I already explained, if you have already carried out these 10 tests as per the recommendation of the standard, then there is no chance of hotspot. So that is how it is. If there is no chance of hotspot, so creating a purposely, you make a mistake and make a hotspot, then try to detect it and try to do something is wrong. While making the installation itself, you ensure that there is no chance of hotspot. That is how these standards are made. So you are on mute, Mr. Dominic.
Okay, sorry. Vishnu is asking where is the suitable place to install AFDD?
It is on the final circuit. So the circuits probably to the sockets of or to the air conditioner. You see, in India, a lot of air conditioner fires are happening. More than 350 incidents are reported in last 1 year. More than 400 people are getting killed. Maybe on the air conditioner circuits you can use it on the final circuits, especially on bedroom.
Vijay Kumar Mani, very important point is raising. Cable tripping tool plays an important role. Need to be calibrated periodically. This have been noticed during many cases through the root cause analysis of electrical fire.
Course, yes, I fully agree to this. It is not only using a proper crimping tool, it is using a properly sized and calibrated crimping tool. Because sometimes less crimping, less pressure is a problem, over pressure is also a problem. You have to use the appropriate pressure.
He's asking, is there any guidance for on cable trimming tool?
Yes, of course, it is there, but I don't remember exactly where it is. It is there in IS 732. I don't remember the clause number.
So Shivaji Biswas, so quick question to you is, I'm getting neutral current in three phase. What type of device I will use to prevent it?
I'm sure in if you are using only three phase, there is no neutral. But you are not talking about three phase. You are talking about three phase plus neutral. In that case, due to unbalances, there can be a neutral current. The best way to handle this is to make the load as much as balanced so that it can be reduced. But today's electronics equipment using SMPS, you need to have a different treatment for that.
Good. Anonymous, Harini, what are the standard used for selection of protective devices? What are the standard for protective
Yeah,
devices?
I already the
And
4.3 and 4.4 of IS 732.
so I'll take the last question. Guidelines on installation of battery chargers in the parking area of the society buildings.
You see, I think there is no guideline as such today for guiding the usage of battery chargers in the society. We are trying to include this in the upcoming national building code. A lot of discussions are going on. Different ministries and different organizations are discussing. I think NBC will have a good solution.
Now there's a lot of comments on chat box. Somebody says we also have need to have similar presentation on lighting protection. So I would like to draw your attention that we did recently on the lighting protection as per IEC, and all these are available. I think that is not available on the blog that is there in NOP. But most of our webinar we have covered vast subject. If you are a member of NFE, I would welcome you to just visit our website. You'll find many answer to your questions, and we can revisit our this thing. Even in fact, this recording, what we are talking today, also will be there in the website, and it will be circulated to all the members. So, wonderful session, enlightening, short and sweet, and I would urge everyone to join us tomorrow from for learning from losses. Again, Mr. Gopa Kumar will be there. It's an interactive session. It is not a presentation. No, so we'll be looking at the report that has come on the Grenfell Tower. What is the commission report says, and what India. So we have National Building Code Chairman Mr. Suresh, former Director of Maharashtra Mr. Deshmukh. We have risk insurance Mr. Kale. Then we have Mr. Deshmukh and Abhishek Chabra from the building testing of materials. So we have a very good panel tomorrow. So I would urge everyone to join us at 11 o'clock in the morning. And we will again come back with new subject. We'll announce in the
There are
our website.
there are few people who raised the hand.
So there are people who raise the hand. You'll be able to speak, sir. Yeah. So I will take. There are three. Bhavendra sir, Sandeep. Please make sure that you speak to the relevant subject. I am allowing Sandeep to speak. If you are there, please go ahead and speak, Mr. Sandeep. You can unmute and speak. Then Sanjay Biswas, Shivaji Biswas. If you can unmute, you are most welcome to speak.
Okay, that is by.
Okay, Amrit Lal want to talk. I'm allowing Amrit Lal to speak.
Yeah, good evening. I just want to tell that there is a guideline from Power Ministry regarding EV charging for high-rise buildings and flat complexes. Somebody was asking about that.
Yeah, yeah. Which is the guideline?
This is 28th June 2024, Bureau of Energy Efficiency. And there is a guideline from 2022 onwards
One of the
from Ministry of Power.
one of the problem in our country is there are so many departments, and each department will make one guideline.
Yeah.
Finally, 5 years, if we look, there will be 25 guidelines guiding 25 directions. This is also a problem. I hope Mr. Amrit agree to me. Not now,
Yeah,
maybe.
that is true. There are, I mean, contradictory guidelines available.
Yeah.
Shivaji Biswas, you want to speak? Please go ahead.
Hello.
Yeah,
Hello.
go ahead. Yeah.
I have already got my answer
Oh,
through
wonderful,
your
sir.
write up. I don't have to ask anything.
Okay, thank you, thank you, thank you so much. Rajan Menon wants to talk. I'll unmute. Very short and sweet question.
Yeah, very nice to see the Governor sir with so much of pain and thought giving such a dedicated address to the public. My question is, shall we have a template for EV charging stations, earthing norms for since that industry is fast growing and nobody knows what exactly to do on the earthing system since it is having multiple sources of earth, two gun of DC with the 30 kW, then scooter charging, all those things will be available for a station. And we need to have a separate lighting circuit or essential power supply on a EV charging station. Shall we have just a single line diagram published in NFE as a benchmarking earthing drawing? Then it will be helpful for the public at large. That is my suggestion.
Thank you. Thank you, sir. Apav sir wants to talk. I'm giving the permission allowed to talk. Apav sir, welcome, sir.
It's a wonderful presentation by GK. Especially, I'm concerned with the last part of it's an embarrassing one. Actually, if the IoT based device is installed as per government norms and any fire happens, then who will be the responsibility? The consumer, as per regulation, the consumer is responsible for every circuit as per regulation. And there is a safety regulation in our country by the Central Authority, and there is a national electric code, and there is an IS 732 wiring practices. But by avoiding all these norms prescribed in the standards, codes, and regulations, how could come without the knowledge of these three entities, that is BAS, CEA, and Ministry of Power? How there could be a regulation or instruction which can comfortably override these three important entities in our country? It can happen in our country only. It's really, we couldn't understand. See, regulation says clearly, and wiring practice says clearly, and IoT device, it will become an illusion if there is no. See, IoT is nothing but a device which can monitor and give information. But the safety subject is not monitoring and informing. It should be automatic. It should be protected automatically. That's why the word automatic protection, everything is there in the standards. But it will send SMS and it will appraise the people. They will come. Before that, everything will collapse. So what we can do, the consumer can provide this illusionary device and they can claim if anything happens, the person, the department, the ministry which issued these instructions will be responsible, not the consumer. Sorry to say, this is my opinion. And NFA has to bring it to the highest level of the country, not the ministry, our Ministry of Power, CEA, BAS, and even the Prime Minister of Office, because day to day we are losing 35 lives out of electrocution and electrical fire. It's a concern. We should take it forward. Thank you. Sorry.
Thank you, sir. Our General Secretary, Secretary General, Rapao sir of NFE, and also former Chief Electrical Inspector of Tamil Nadu, who just spoke to us. You know, he's also raising very serious concern about so-called IoT devices, monitoring electrical devices can save lives. There is no electrical short circuit, and so on and so on. I'm sure our Mumbai chapter of Mumbai, they were almost present here, also take up this very seriously with the government. You know, this can in a huge cost that the people consume as a consumer. You need to invest huge money into this to make it uh, you know uh, applicable to the new standard or a guide government order. It's a GOI. Government says you must, every building must have it, but how much how much money that you can pump in, God only knows. And this we need to take it up seriously with the government of Maharashtra. Let's see how we move it. And we have last question I'll take for today. Ravi Verma is there. Mr. Ravi Verma, are you there? I'll allow you to talk. Yeah,
Hello, good evening, sir.
good evening.
Sir, as you know, the power we receive from the government, like DESCOM, is a fluctuating in nature. So, to protect our equipment, we will be using stabilizers. So, when sometimes like stabilizer is now it's itself became a cause of accident. So, what protection should we take to like stabilizer to be stable, or any alternative there to the stabilizer?
Actually, using stabilizer creates more problem to you. Example, once when the stabilizer is in boosting or bucking mode, then the impedance of the circuit is increased. As a result, safety is at risk. The automatic disconnection of protective devices may be a problem. Number two, as per the rules regulations, the distribution company is supposed to give you electricity which is within certain tolerance. So such drastic fluctuations where we need to use a stabilizer, that situation has to be avoided by the DISCOM. But unfortunately, the situation of our DISCOMs, all of us know very well. More than that, there is a third problem. The fault in the HT system is creating a lot of failure in the low voltage consumer premise. So the problems are already explained in IS 732, especially in clause 4.5, but who will implement is the question. We are also putting our efforts to educate the DISCOM on simple measures with which these safety measures can be implemented. I would recommend, Apau sir, you would like to answer anything on this?
Nothing, sir. Nothing, sir. Nothing. I have expressed my concern already.
Yeah. Thank you. So, need some time. Thank you very much.
Okay, I'll have another gentleman. Can you talk, Mr. Sahil?
Okay,
Sahil, we would like to-
thank you. Can you hear me now? Am I audible?
Yeah.
Okay, so I'm from Punto Corporation, Jaipur. So we have made a device which is installed in our homes and offices and industries. We are 100% making safe that there will be no incident of fire because of short circuit. Why? Because in case of short circuit, our device, if installed, completely shuts down the power supply. We've got this technology patented, and there is one more aspect. Once this device is installed in
Sorry,
any
man. You are
once this
not
device
high
once
tech
it,
system. You are talking about an isolation transformer with a
yes,
protect.
yes,
Technically, the standards we say IT system. IT system means you put an isolation transformer. The secondary side of the isolation transformer is unearthed. As a result, even if somebody touches a live conductor, people don't get shock. This is not
absolutely.
technology, and this. If somebody gave patent to this particular device, then we have to really look at the capability of the patent office. This is nothing new. This has been there in the science since the invention of electricity. So during the invention, during 1880s, the system used is IT, unearthed system. So then they switched over to earthed system due to the problems of double fault. So don't say that this is an innovative system or this is something special. This is basically an IT system. In electrical technology, we have earthed system and unearthed system. You are creating an unearthed system. Now, if you are properly rating your MCBs and protective devices, of course, in case of any abnormality, it should trip. So there is nothing special. I hope you understood. These things can be explained to a house owner who doesn't know about electricity, but it would be please restrict in explaining such things to an engineer's forum. Thank you very much.
Okay, sir. It's a wonderful interactive session at the end we had, and we will come back to you with our next topic very soon. And
Evening, sir, I would like to add one more issue. I think these patented and fashionable no shock, no fire things, these foolish things are actually spoiling our market. Sorry to say that. If you put a proper perspective, it is supposed to work. And now to solve the problem, people think that I have invented something new. This is no invention. This is there since the invention of electricity. What to say? Sorry to say that the knowledge of electrical engineer has went to such a low level that these things are also people start believing such foolish things. Sorry to say that.
okay, sir. Let's keep moving and look forward to see you tomorrow. And please do join. And we will come back with our next session. Also, if people are from Indore, we are coming to Indore for the 29th workshop on National Electrical Code of India with partner with BIS. We are there in Indore on 18th of October. So those who are interested, please do join us and support us. Thank you. Have a wonderful, great evening. Thank you, Mr. Gopa Kumar. Thank you, Apav sir, for coming in the last moment. And look forward to see you again. Thank you very much. God bless you all. Bye-bye.